Hello, in this lecture we will find out the area of the green shape in 3 different methods. In the drawing we have rectangle ABCD, and we also know that AE equals to ED, BE equals to 7 units, and BF equals to 9 units. And we also know that angle ABE, this angle equals to theta, and also angle EBF, this angle equals to also theta. And we want to find out the area of this green shape. So we start with the first method. In the first method, we will extend side DC and BE until they intersect each other. Until they intersect with each other. And we will define the intersection point between the extended BE and the extended DC as point P. This point is defined as point P. And actually we know that DC is one side of rectangle ABCD, therefore it is absolutely a straight line, and when we extended the straight line DC by straight line, CP will be still a straight line. And we have rule, first of all, we know that all the angles inside a rectangle are right angles, so this angle is a right angle, it equals to 90 degrees. This angle is also a right angle, it equals to 90 degrees. And this angle is also a right angle, that is to say it equals to 90 degrees. And we actually have rule number 1 that relates to straight line. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So I will read again rule number 1. Rule number 1 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So actually, if we focus on this side of the straight line CP at point D, we know that the sum of the angles is equal to 180 degrees. That is to say, angle PDE, this angle that we will define as angle X, plus this angle that is 90 degrees must be equal to 180 degrees. So angle X plus 90 degrees equals to 180 degrees. Here we will subtract 90 degrees from this equality, and we will get that angle X equals to 180 degrees minus 90 degrees equals to 90 degrees. So angle X is the right angle. So we can change this angle PDE, angle X, as a right angle. And we also know that the opposite sides of a rectangle are parallel to each other. That is to say, AB is parallel to the straight line DC. But we know that CP is one straight line. Therefore, actually, side DC and side CP are located on the same straight line. Therefore, if AB is parallel to DC, then AB will be also parallel to PC. So I'll write it down. AB is parallel to PC. And we also have rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. I repeat again on rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. So here we have those two angles, that is to say angle PEPD and angle ABE are defined as alternating angles, so they are located between the parallel lines AB and PC, therefore they are equal to each other according to rule number 2. So we can write down that angle ABE, this angle, is equal to angle EPD, this angle, and we know that angle ABE, this angle, is equal to theta. So this angle equal to theta. So it is given us in the question that angle ABE equals to theta. From this equality, we will conclude that angle EPD also equals to theta. Angle EPD also equal to theta. In the next step, we will prove that those two right triangles can go into each other. That is to say, we will prove that this right triangle, green triangle, triangle ABE, is congruent to this right triangle, triangle PED. So first of all, we just right now proved that those two angles are equal to each other, so angle ABE of this green triangle is equal to angle EPD, this angle, and they are both equal to theta. I'll repeat again. Angle ABE equals to angle EPD, they are both equal to theta. We know that those two angles, they are also equal to each other, they are both right angles, so angle, this angle, angle BAE, is equal to this angle, angle PDE, and they are both equal to 90 degrees, they are right angles. I will repeat again. Angle BAE equals to angle PDE equals to 90 degrees. And we also know that those two angles, they are equal to each other because of the fact that those two angles are defined as vertex angles, and we have a rule that states that vertex angles are equal to each other. So this angle, angle AEB, is equal to this angle, angle PED, according to the rule that vertex angles are equal to each other. So I'll repeat again. Angle AEB equals to angle PED, they are both equals, because of the fact that they are vertex angles and vertex angles are equal to each other. So we proved that all three angles of the green right triangle can went to all the three angles in triangle PED. And we also know that AE equals to ED according to what is given us in the question. AE equals to ED. repeat again. AE equals to ED. It is given us in the question. So actually we proved that those two right triangles can go into each other according to angle side angle rule. Why? Because we proved that those two angles and the side AE that is between them can congruent correspondingly to those two angles and the side that is located between those two angles, that is to say ED in the right triangle EPED. Therefore we proved that those two right triangles can go into each other according to angle side angle rule. So I'll write it down. We proved the triangle ABE congruent. This is the sign of congruent for triangle PED according to angle side angle rule. So what is angle side rule? First of all, I repeat again, triangle ABE congruent to triangle PED according to angle side angle rule. So what is angle side angle rule? Angle side angle rule says that if two angles and the side that is included between those two angles in one triangle congruent correspondingly to two angles and the side included in another triangle then the triangles congruent according to side angle rule. So I'll read again side angle rule. According to side angle rule, if two angles and the side that is included between those two angles in one triangle and congruent correspondingly to two angles and the side that included in another triangle, then the triangles congruent to each other according to side angle rule. And I repeat again, we proved that those two angles, those two angles and the side that included, that is to say, DE between those two angles in the right triangle PDC, congruent correspondingly to those two angles and the side that included between those two angles, that is to say AE. Therefore, we proved that those two right triangles congruent to each other according to side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that BE equals to EP, I repeat again, we conclude that B equals to EP according to the rule that corresponding sides and congruent triangles are equal to each other, and so those two triangles congruent to each other, therefore the corresponding sides BE and EP will be equal to each other. But we know that BE equals to 7 units. It is given us the question. Okay. From this equality we will conclude that EP also equals to 7 units. So I can write here that EP equals also to 7 units. And in the next step, we define the area of quadrilateral FB, the area of quadrilateral EBFD as Y. So the area of quadrilateral EP FD is defined as Y. The area of quadrilateral EBFT is defined as y. This is the sign for the area. 2 brackets is the sign of the area. And we will define the area of the green right triangle AB as x. But because of the fact that those two triangles congruent to each other, we will conclude that they have also the same areas. So if the area of triangle ABE is x, then the area of triangle PED will be also equal to x. And actually, the area of the green shape is equal to x plus y, so I'll write it down. The area of the green shape is equal to x plus y, and the area of triangle PBF, this triangle, will be also equal to x plus y. So we found out that the area of triangle PBF is equal to the area of the green shape, so we will find out the area of the green shape in this way. We will find out the area of triangle PBF, and in this way we will find out the area of the green shape. Okay. So we actually know that triangle PBF is an isosceles triangle. I'll repeat again. Triangle PBF is an isosceles triangle because it has two angles that are equal to each other, that is to say, both angles are equal to theta. And we have rule number 3 that relates to isosceles triangle. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. So I read rule number 3 again. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. Okay? So, what is the meaning of rule number 3? The meaning of rule number 3 is if we have an isosceles triangle actually we know that triangle ABC is an isosceles triangle, so I will draw it. So this is triangle ABC. Actually, triangle ABC is an isosceles triangle because of the fact that it has two angles that are equal to each other, both of them are equal to theta. And we know that the base of the isosceles triangle ABC is BC. So if from the vertex A we will draw median to the base BC, so this is the median, and we will define the touching point between the median and side BC as point O. So actually the median bisects side BC, that is the base. So if OB equals to X, then OC will be also equal to X. But according to rule number 3, it is not the median to the base, it is not only bisects the base, but it is also perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? So, when you draw median to the base in an isosceles triangle, then that median will be perpendicular to the base. In this case, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so we can implement rule number 3 in our drawing. Because we have the isosceles triangle PBF, because it has two angles that are equal to each other, both of them are equal to theta, and the base of this right triangle PBF is E, the base is PB, this is the base. So if you roll from point F perpendicular to the base, so the median to the base of the isosceles triangle PBF bisects the base into two equal parts, that is to say PE equals to 7 units and EB also equals to 7 units, but it is not only bisect the base PB into two equal parts, but it is also perpendicular to the base, that is to say this angle equals to 90 degrees and this angle is equal to 90 degrees. And so if this angle is a right angle, then triangle BEF is a right triangle, so we can implement the Pythagoras theorem. The right triangle BEF, in order to find out the value of EF. So in triangle EBF, according to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually you can see it clearly on the drawing. So BF is the hypotenuse of the right triangle EBF, the green right triangle EBF. So BF square is 9 square, 9 square is 81. And it equals to BE square, BE is 7, so B square is 49. Plus EF square. So I repeat again. The right triangle, the right green triangle BEA, 81 equals to EF square plus 49. We will subtract 49 from this equality and we will get that 81 minus 49 is 32. 32 equals to EF square. So 32 equals to EF square. We take out of this equation and we will get EF so 32 equals to EF square here we take a root out of this equation number 2, and we get that EF equals to the square root of 32, but we know that 32 is 16 times 2, so I write it down. And the square root of 16 is 4. So in conclusion, we found out that EF equals to 4 times square root of 2. So here we can write down that EF equals to 4 times square root of 2. So what is the area of triangle PBF? The area of triangle PBF is equals to the base of the triangle times the height of the base over 2. The base times the height over 2, that is the area of triangle PBF, the isosceles triangle PBF. So the base of the isosceles triangle PBF is PB. The base is PB, the height to the base is EF over 2. So we found out that the area of the isosceles triangle PBF equals to PB is 7 plus 7, that is to say it equals to 14. Times EF is 4 times 2. Four times square root of 2 over 2. So the area of the isosceles triangle PBF, that is also the area of the green shape, equals to 14 times 4 times 2 over 2. 14 over 2 is 7, so I write it down. So the area of triangle PBF, that is the area, also the area of the green shape, will be equal to 7 times 4 times root of 2. Seven times 4 is 28 times root of 2, so they are now the green shape. Equals either to 28 times root of 2 square units, or in terms of numbers, it equals to 39.6 square units. I repeat again. The area of the grid shape equals to either 28 times root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we will rely on rule number 2, that alternating angles between parallel lines are equal to each other. We know that AB is parallel to DF according to the rule that the opposite sides of a rectangle are parallel to each other. So if AB is parallel to DF, then AB will be also parallel to part of DF, that is to say it will also parallel to FC. So we know that AB is parallel to FC, and we have those two angles are defined as alternating angles, and they are located between the parallel lines AB and FC, therefore they are equal to each other. So if this angle is 2 theta, then this angle will be also equal to 2 theta. And we also know that all the angles inside a rectangle are right angles, they are equal to each other. So we will focus on the right triangle, the right green triangle, triangle ABE. I will draw it again. On the right triangle, triangle ABE. Here we will define line segment AE is x. So if line segment AE equals to x, then you know that AE equals to ED, so ED will be also equal to x. So here we have AE equals to x, BE equals to 7. So In the right triangle EEB, sinus theta equals to x over 7. And in the right triangle BFC, first of all, we know that the opposite sides of a rectangle are equal to each other, that is to say AD is equal to BC, but we know that AD equals to 2x, so BC will be also equal to 2x. So here in the right triangle BFC, sinus 2 theta equals to x over 9. Sinus 2 theta equals to 2x over 9. I will repeat again. In the right triangle BFC, sinus 2 theta equals to 2x over 9. But we know that we have a trigonometric identity that states that sinus 2 theta equals to 2 sinus theta cosine theta. I'll repeat again. We have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosine theta. So we can substitute sinus theta in equation number 2 by 2 sin theta cosine theta. We'll do it and we'll get it 2 sin theta cosine theta equals to 2x over 9. And we know that sinus theta equals to x over 7 according to equation number 1. So in equation number 2 we get that 2 sin theta equals to 2 times x over 7 times cosine theta equals to 2x over 7 . And we have 2x on both sides of the equation, so 2x will get cancelled. What is left for equation number 2 after we cancelled 2x? What is left? It is actually cosine theta over 7 equals to 2x equals to 1 over 7. 2x over 9 equals to 1 over 7. So this cosine theta over 9 equals to 1 over 7. We will multiply this equation number 2 by 9, and we will get that cosine theta equals to 7 over 9 So we found out that cosine theta equals to 7 over 9. Cosine theta equals to 7 over 9, so I write it in a new page. Cosine theta equals to 7 over 9. What is the meaning of cosine theta equals to 7 over 9? It means that we have a right triangle the side that is near theta is 7 and the hypotenuse is 9. Here the missing side is this side. We define it as S. According to the Pythagoras theorem, S square plus 7 square equals to 9 square. So S square, 7 square is 49 equals to 81. We subtract 49 from this equality and we will get that S square equals to 81 minus 49 is 32. So we take out all of this equation and we will get that S equals to square root of 32. So S equals to 32 is 16 times 2, so we will write it down. Equals to 4 times square root of 2. We found out that S equals to 4 times square root of 2. So from this drawing you can see that sinus theta equals to 4 times square root of 2 over 9. But according to equation number 1, sinus theta equals to x over 7. So we'll substitute sinus theta by 4 times square root of 2 over 9, and we'll get that we multiply equation number 1 by 7, we'll get that x equals to 28 times square root of 2 over 9 square units. So I found out that x equals to 28 times square root of 2 over 9. So x equals to 28 times square root of 2 over 9. So x equals to 28 times square root of 2 over 9. So 2x will be equal to 56 times square root of 2 over 9. So here BC that equals to 2x will be also equal to 56 times square root of 2 over 9. In the next step we will focus on the right triangle ABE. On the right triangle ABE. Cosine theta equals to AB over 7. But we already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta by 7 over 9. So it equals to AB over 7. We will multiply this equation by 7 and we'll get that AB equals to 49 over 9. Here AB equals to 49 over 9. But we know that the opposite sides of a rectangle are equal to each other, so that means that AB equals to DC. But AB equals to 49 over 9, so DC will be also equal to 49 over 9. In the next step, we'll focus on the right triangle BFC. On the right triangle BFC, according to the Pythagoras theorem, here cosine 2 theta equals to FC over 2x. Cosine 2 theta equals to FC over 9. So here we will multiply this equation by 9, and we get that FC equals to 9 times cosine 2 theta but we have the trigonometric identity that cosine 2 theta equals to 2 times cosine square theta minus 1. So we can substitute cosine 2 theta in this equation by 2 cosine square theta minus 1, so we did it and we will get that FC equals to 9 times 2 cosine square theta minus 1 we've already found out that cosine theta equals to 7 over 9, therefore cosine square theta will be equal to 7 over 9 square. So we'll substitute cosine square theta by 7 over 9 square. Here we will get that FC equals to 9 times 2 cosine square theta is 49 over 81 minus 1. So FC equals to 2 times 49 is 98 minus 81 minus 81. So FC equals to 9 times 98 minus 81 is 17 over 81. So we substitute cosine square theta by 7 over 9 square. So FC here we will divide the numerator and the denominator by 9, and we will get that FC equals to 17 over 9 here we can add down that FC equals to 17 over 9. We know that df equals to dc minus fc. That is to say df equals to dc is 49 over 9 minus fc is 17 over 9. So df equals to 49 minus 17 over 9 is 32 over 9. df equals to 32 over 9. So now you can find out the area of the green shape. This is actually the area of a piece ABDF. The area of trapeze ABDF will be equal to AB plus DF times the height AD over 2. So the area of trapeze ABDF equals to AB plus DF times AD over 2. So the area of trapeze ABDF equals to AB, that is 49 over 9, plus DF, that is 32 over 9, times the height, that is 56 times square root of 2 over 9 over 2. Here 49 plus 32 is 81, so I write it down. Here 81 over 81 is 1. So in conclusion, we found out that the area of trapeze ABDF, this is actually the area of the green shape, equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So in the next step, I will present to you how to find out the area of the green shape, ABDF, according to a third method. In the first method, we will draw perpendicular from point E to BF. So this angle is equal to 90 degrees, and this angle also equals to 90 degrees. we define the touching point the perpendicular on BF is point M. So we know that all the angles inside the rectangle are right angles, so this angle equals to 90 degrees, and this angle also equals to 90 degrees. This angle also equals to 90 degrees. So we prove that those two right angles can go into each other. So we relate to triangle ABE. And triangle BEM. First of all, we know that those two angles are equal to each other. They are both equal to theta, so angle ABE equals to angle EBM, and they are both equal to theta according to what is given us the question. So angle ABE equals to angle EBM equals to theta. We also know that those two angles they are equal to each other, they are both right angles. Angle BAE equals to angle EMB. They are both equal to 90 degrees. Angle BAE equals to angle EMB, they are both equal to 90 degrees. And those two angles, they are equal to each other according to third angle theorem. So angle BEM or angle AEB is equal to angle BEM according to third angle theorem. I repeat again. Angle AEB equals to angle BEM according to third angle theorem. What is third angle theorem? Third angle theorem is that if you have two angles that are equal in one triangle that can go into two angles in another triangle, then the third pair of angles must also congruent. And here we have those two angles congruent to those two angles in triangle EBM, therefore those first pair of angles must also congruent. Okay, and BE equals to BE it is a common side that belongs to both triangles. So BE equals to BE is the common side that belongs to both triangles. Therefore, we prove that those two triangles can go into each other according to angle side angle rule, because we have those two angles and the side that is between them in this triangle ABE can go to those two angles, and the side BE that is between them in triangle EBM, therefore those two triangles can go into each other according to angle side angle rule. So actually triangle ABE congruent to triangle BEM according to angle side angle rule. Triangle ABE congruent to triangle BEM according to angle side angle rule. And for the fact that those two triangles can go into each other, we conclude that AB equals to BM, AB equals to BM according to the rule that corresponding sides in congruent triangles are equal to each other, and if AB equals to Y, then BM also equal to Y. And we will also conclude that AE equals to EM, and if A equals to X, then EM also will be equal to X. And we know that AE equals to ED, it is given us in the question, so ED will be also equal to X. So in the next step, we will join together points E and F by a straight line. And we will prove that those two triangles can go into each other. We will also actually prove the triangle EDF can go into triangle EMF. First of all, we know that EM equals to ED equals to X. Note that also EF equals to EF, this is the common side that belongs to both triangles. And those two angles are equal to each other, they are right angles. So angle EMF is equal to angle EDF. And they are both equal to 90 degrees. So we actually proved that those two triangles can go into each other according to rule number 5. So what is rule number 5? According to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other and read number 5 again. If the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. So we actually proved that the hypotenuse EF and the perpendicular EM in the right triangle EMF congruent to the same hypotenuse EF and the perpendicular ED in the right triangle EDF. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. We actually proved that triangle EMF congruent to triangle EDF according to rule number 5. And for the fact that those two triangles can go into each other, we will conclude that MF equals to DF Actually, MF is equal to 9 minus y. So if MF equals to DF and MF equals to 9 minus y, then DF will be also equal to 9 minus y. And we know that the opposite sides of a rectangle are equal to each other, that is to say AB equals to DC. And if AB equals to y, then DC will be also equal to y. And FC equals to DC minus DF. FC equals to DC minus DF. So FC equals to DC is y, minus DF is 9 minus y. Y minus 9 minus y is equal to y minus 9 minus y is plus y. So in conclusion, we found out that FC equals to 2y minus 9. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to BC. But AD equals to x plus x, that is to say, AD equals to 2x, therefore BC will be also equal to 2x. And in the right triangle, ABE, this right triangle, according to the Pythagoras theorem, x squared plus y squared equals to 49. And if we focus on the right triangle, triangle BFC, according to the Pythagoras theorem, BF squared is 9 squared is 81, equals to FC squared plus BC squared. I'll repeat again. In the right triangle BFC, according to the Pythagoras theorem, 81 equals to FC squared plus BC squared. FC equals to 2y minus 9, so FC squared will be equal to 2y minus 9 squared. BC equals to 2x, so BC squared will be equal to 4x squared. So in conclusion, we found out that according to equation number 2, 81 equals to 2y minus 9 squared plus 4x squared. We'll open the brackets here and we'll get that 81 equals to 2y minus 9 squared with 4y squared plus 81 minus 36y plus 4x squared. We have 81 on both sides of the equation, so 81 will get cancelled. 0 equals to 4 xy plus y squared, x squared plus y squared minus 36y. We will add 36y to equation number 2 and we will get that 36y equals to 4 times x squared plus y squared. According to equation number 1, x squared plus y squared is 49, so we substitute x squared plus y squared by 49 in this equation number 2, and we get that 36y equals to 4 times 49. We divide the equation number 2 by 4 and we get that 36 over 4 is 9, is 9y equals to 49. We divide this equation number 2 by 9 and we got that according to equation number 2, y equals to 49 over 9. Y equals to 49 over 9. According to equation number 1, x squared plus y squared equals to 49. So we'll substitute y squared by 49 over 9 squared from equation number 2. We'll put it in this equation number 1 and we'll get it x squared plus 49 over 9 squared equals to 49. 49 is 7 squared, so in conclusion we get that x squared equals to 7 squared minus 49 over 9 squared. So here we use the trigonometric identity that a squared minus b squared equals to a plus b times a minus b. Here we know that b squared equals to 0. A is 7 and b is 49 over 9. So according to equation number 1, x squared equals to 7 plus 49 over 9 times 7 minus 49 over 9 we multiply 7 by 9 and then divide it by 9 in order to have a common factor with 49 over 9. And we'll get that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. So x squared equals to 112 over 9 times 63 minus 49 is 14 over 9. So x squared equals to 14 times 8 times 14 times 14 over 9 times 9. Eight is 2 times 2 times 2, so we'll substitute 8 by 2 times 2 times 2, and we'll get that x squared equals to 2 times 2 times 2 times 14 times 14 over 9 times 9. We take a root out of equation number 1, and we will get that x equals to the square root of 2 times 2 times 2 . So x equals to the square root of 2 times 2 is 2, the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. In the root we have only left with 2, so x equals to 2 times 14 is 28 times square root of 2 over 9. Now we can find out the area of trapezoid BDF. The area of trapezoid BDF is equal to AB plus DF times AD over 2 . So the area of the green shape is equal to AB's, it is actually equal to Y plus DF is plus 9 minus Y times AD is 2x over 2. Here 9 minus 9 y minus y is 0, over 2 is 1, So they are of the green shape. Is equal to 9x. We've already found out that x equals to 28 times square root of 2 over 9. 9 over 9 is 1. So in conclusion, we found out that they are of the green shape according to the first method. It equals to 28 times square root of 2 square units. Now in terms of numbers, it equals to 39.6 square units. So now let's summarize the lecture. So in the first method, we extended CD and BE until they intersect with each other at point P, and we actually know that CD is one side of rectangle ABCD, therefore it is absolutely a straight line. And when we extended CD, a straight line CD by a straight line, it will be still a straight line, so CP is a straight line. So you know that CP is a straight line, and we have goal number 1. It states that the sum of the angles on one side of a straight line is equal to 180 degrees. So we know that PC is a straight line, so if we focus on this side of the straight line PC at point D, the sum of the angles must be equal to 180 degrees. So that is to say this angle is angle X and this angle is 90 degrees. So X plus 90 degrees equals to 180 degrees. We'll subtract 90 degrees from this equality and we will get that X equals to 90 degrees. So found out that this angle is a right angle, it equals to 90 degrees. Then we know that AB is parallel to DC according to the rule that the opposite sides of a rectangle are parallel to each other. So if AB is parallel to DC, AB will be also parallel to PC because they are located on the same straight line. And those two angles, they are defined as alternating angles, and according to rule number 2, they are equal to each other. So rule number 2 states that alternating angles between parallel lines are equal to each other. So angle AB, those two angles, they are defined as alternating angles and they are located between the parallel lines AB and PC, therefore they are equal to each other. That is to say angle ABE equals to angle EPD, angle AB equals to angle EPD, but according to what is given us in the question, angle AB equals to theta. Angle ABE equals to theta. From this equality we conclude that angle EPD also equals to theta, so this angle equals to theta. Then we proved that those two right angles can go into each other. Why they can go into each other? First of all, we just right now proved that those two angles are equal to each other. Both of them are equal to theta, so angle AB equals to angle EPD equals to theta. Those two angles are right angles, they are equal to each other. So angle BAE equals to angle PDE equals to 90 degrees. And those two angles, they are vertex angles. And we have the rule that vertex angles are equal to each other. So angle AEB equals to angle PED, according to the rule that vertex angles are equal to each other. And we know that AE equals to ED, it is given us in the question that AE equals to ED. So we actually proved that triangle ABE can go into triangle PED according to angle side angle rule. So what is angle side angle rule? Angle side angle rule states that if two angles in the side that is included between those two angles in one triangle can went correspondingly to two angles in the side that included in another triangle, then the triangles can go into each other according to angle side angle rule. And we actually proved that those two angles and the side that included between those two angles, that is to say AE, in the right triangle BAE. This triangle can went to those two angles and the side that includes between those two angles, that is to say ED, in the right triangle PDE. Therefore, we prove that those two right triangles can point to each other according to angle side rule. And from the fact that those two triangles can point to each other, we conclude that BE equals to EP. BE equals to EP according to the rule that corresponding sides in congruent triangles are equal to each other. So BE equals to 7 units. B equals to 7 units, therefore EP will be also equal to 7 units. And we actually have this quadrilateral EBFD. We defined the area of this quadrilateral as phi. The area of quadrilateral EBFD is defined as phi, and we define the area of the right triangle AB as x. So the green area will be equal to x plus y, but we know that triangle ABE can go into triangle EPD, therefore they also have the same areas. The area of triangle ABE is equal to x, so therefore the area of triangle EPD will be also equal to x. So the area of triangle PBF is equal to x plus y. Triangle PBF is equal to x plus y. And so in the green area also equals to x plus y. So we can find out the area of triangle PBF, and in this way we will find out the area of the green shape. And we know that triangle PBF is an isosceles triangle. This triangle is an isosceles triangle because it has two angles that are equal to each other. And we have rule number 3 that relates to isosceles triangle. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have this triangle ABC is an isosceles triangle, but why? Because it has two angles that are equal to each other. Both those two angles are equal to theta. So the base of triangle ABC is AB, and if from point A we draw median to the base PC, then the median bisects the base. But according to rule number 3, it is not only bisect the base, but the median also is perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So we actually can implement rule number 3 in our drawing, because in our drawing we have the isosceles triangle PBF, and the base of the isosceles triangle PBF is PB, and if from point F we draw the median FE, then the median is bisect the base PB, but it is also perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And because of the fact that this angle is a right angle, then triangle EBF is a right triangle. So we can implement the Pythagoras theorem in the right triangle EBF. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. So BF square is 81 equals to BE square plus EF square. 81 equals to EF square. And EB square is 7, so 7 square. EB is 7, so EB square is 7 square. 7 square is 49. We subtracted 49 from this equation number 1, and we got that EF square equals to 81 minus 49 is 32. We took a root out of equation number 1, and we got that EF equals to 32. EF square equals to 32. We took a root out of equation number 2, and we got that EF equals to the square root of 32. 32 is 16 times 2. So in conclusion, we got that EF equals to 4 times square root of 2. And now we can easily calculate the area of the isosceles triangle PBF. This is also the area of the green shape. The area of the isosceles triangle PBF equals to the base of the triangle times the height over 2. The base is PB, the height is EF, all divided by 2. BP equals to 14 units. EF equals to 4 times square root of 2 over 2. So in conclusion, the area of triangle PBF, this is also the area of the ring shape, it equals to 14 times 4 times square root of 2 over 2, 14 over 2 is 7. So in conclusion, the area of triangle PBF, this is also the green area, equals to 7 times 4 is 28 times square root of 2 square units, so we got some numbers, it equals to 36.9 square units. So we finished with the first method. Then I presented to you how to find out the area of this green shape according to a second method. According to the second method, we have those two angles, and they are alternating angles. We know that AB is parallel to DC because of the fact that the opposite sides of a rectangle are parallel to each other. So if AB is parallel to DC, then AB will be also parallel to FC. So AB is parallel to FC, and we have those two angles that are located between parallel lines, therefore they are equal to each other according to rule number 2. But this angle equals to theta plus theta, this is theta equals to 2 theta. So this angle will be also equal to 2 theta. And we know that all the angles inside the rectangle are right angles. So 1, 2, 3, those 3 angles are right angles. Then we focus on the right triangle ABE. Here sin of theta equals to x over 7, and in the right triangle BFC, sinus 2 theta equals to 2x over 9. Sinus 2 theta equals to 2x over 9. But sinus 2 theta equals to 2 sinus theta cosinus theta. So we substituted sinus 2 theta by 2 sinus theta cosinus theta. And we got that 2 sinus theta cosinus theta equals to 2x over 9 according to equation number 2. So here we know that sinus theta equals to x over 7 according to equation number 1. So we substituted sinus theta here by x over 7. We got this equation and we divided both sides of the equation by 2x, and we got that cosine theta over 9 equals to 1. Cosine theta over 7 equals to 1 over 9. We multiplied this equation by 7, and we got that cosine theta equals to 7 over 9. So we know that cosine theta equals to 7 over 9. We know that cosine theta equals to 7 over 9. What does it mean that cosine theta equals to 7 over 9? It means that we have a right triangle with the hypotenuse is 9 and the side that is near angle theta is 7 units. So here we can implement the Pythagoras theorem. That means that s squared plus 7 squared equals to 9 squared. S squared is 49. 9 squared is 81. We subtracted 49 from this equation and we got that s squared equals to 42. We took out of this equation, we got that s equals to the square root of 32. 32 is 16 times 2. And the square root of 16 is 4. So in conclusion we found out that s equals to 4 times square root of 2. And we have already found out that here sinus theta equals to 4 times square root of 2 over 9. Then, according to equation number 1, sinus theta equals to x over 9. So we can substitute sinus theta here by this expression. We did it and we got that 4 times square root of 2 over 9 equals to x over 7. We multiplied the equation number 1 with 7 and we got that x equals to 28 times square root of 2 over 9. So we can write here that x equals to 28 times square root of 2 over 9. Therefore, 2x is 56 times square root of 2 over 9, and AD equals to BC, therefore BC will be also equal to 2x. That is 56 times square root of 2 over 9. Then in the right triangle ABE, cosine theta equals to AB over 7. Here, but we know that cosine theta equals to 7 over 9. So we can substitute cosine theta by 7 over 9. So 7 over 9 equals to AB over 7. We multiplied this equation by 7 and we got that AB equals to 49 over 9. So we found out that AB equals to 49 over 9 and CD equals to AB, so CD will be also equal to 49 over 9. And then in triangle BFC, the lower triangle, cosine 2 theta equals to FC over 9. FC over 9. So FC, we multiply this equation by 9 and we got that FC equals to 9 times cosine 2 theta. And we have that trigonometric identity that cosine 2 theta equals to 2 cosine theta, 2 cosine square theta minus 1. So I can substitute cosine 2 theta by 2 cosine square theta by minus 1. We did it. We got this equation, and then we know that cosine theta equals to 7 over 9, so cosine square theta will be equal to 7 over 9 square. So we can substitute cosine square theta here by 7 over 9 square. We did it. We got this equation. And in the end we got that FC is equal to 17 over 9. FC equals to 17 over 9. Then dF equals to dC minus FC. dF equals to dC minus FC. dC equals to 49 over 9 and FC equals to 17 over 9. So dC will be equal to 39 over 32 over 9. If dC equals to 32 over 9. So now we can easily find out the area of trapezoid ABCDE. This is also the area of the green shape. The area of trapezoid ABDF is AB plus DF times AD over 2. Then, so the area of trapezoid ABDF equals to AB plus DF times the height AD over 2. AB is 49 over 9, DF is 32 over 9, and AD is 56 times root of 2 over 9. So we got this expression. 49 plus 32 is 81. So the area of trapezoid ABDF equals to 81 over 81 is 1. So 81 will get cancelled, and what is left here? 56 over 2 is 28. So in conclusion, we found out that the area of the green shape equals to either 28 times root of 2 units, or in terms of numbers, it equals to 39.6 square units. So we finished with the second method, and then I presented to you how to find out the area of the green shape according to a third method. In the third method, we actually made a construction. From point A, we draw perpendicular to BF. This angle is 90 degrees and this angle is also 90 degrees. The touching point between the perpendicular and BF is point M. Then we prove that those two triangles can run into each other. First of all, we know that those two angles are equal to each other. They are both equal to theta, so angle ABE equals to angle EBM equal to theta. And those two angles are right angles, therefore they are equal to each other. So angle VAE equals to angle EMB equals to 90 degrees. And those two angles are equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem says that if you have two angles to one triangle get that congruent to angles to another triangle, then the first pair of fingers must also congruent. And what is called agathon, if you triangles in one triangle that congruent to triangles in another triangle, then the third pair of fingers must also congruent. So if we have two angles in this right triangle congruent, here two angles in triangle ABE congruent to two angles in triangle EBM. So we have two pairs of fingers that congruent with those two triangles. Therefore, this third pair of fingers must also congruent. That is to say, those two angles will equal to each other. Angle AB equals to angle EM according to Pythagorean theorem. And we also know that EB is a common side. That is to say, it belongs to both triangles. So EB equals to EB is a common side. So we actually proved that triangle ABM congruent to triangle ABE is congruent to triangle BEM according to angle side angle rule. Here we have those two angles and the side that is included between term BE in this triangle congruent to those two angles, and the side included between them. This is to say BE, therefore those two triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we conclude that BA equals to AE, or AB equals to BM, AB equals to BM. And we also conclude that AE equals to EM. We defined AB as Y, so but because of the fact that AB equals to BM will be also equal to Y, and we defined AE as X, and we know that AE equals to EM, therefore EM will be also equal to X. Okay. And then we join together points E and F by straight line, and we prove that those two right triangles congruent to each other. Why that congruent to each other? First of all, we know that EM equals to ED equals to X, EM equals to ED equals to X, and EF equals to itself. It is a common side that belongs to both triangles, and we have also those two right triangles that congruent to each other. So here we actually prove that those two triangles congruent to each other according to rule number 5. What is rule number 5? Rule number 5 states that if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. Here we have the hypotenuse EF and the perpendicular ED in the right triangle EDF congruent to the same hypotenuse EF and the perpendicular EM in the right triangle EMF. Therefore, those two triangles congruent to each other according to rule number 5. Okay, from the fact that those two triangles congruent to each other, we conclude that MF equals to DF. MF equals to DF. And what is the value of FC? FC equals to DC minus DF. FC equals to DC minus DF. So FC equals to DC is Y, and DF is 9 minus Y. So FC equals to Y minus 9 minus Y. It is actually 2y minus 9, and in the right triangle ABE, here x squared plus y squared equals to 49, and in the right triangle BFC, the square of the hypotenuse is FC squared 81 equals to FC squared plus BC squared, 81 equals to FC squared plus BC squared, so 81 equals to FC is 2y minus 9, so FC squared is 2y minus 9 squared, plus BC squared. BC is 2x, so BC squared is 4x squared. We open the brackets here and we got this expression. We have 81 on the left side of the equation, so 81 will get cancelled. And then here we took 4 as a common factor, and we got that 0 equals to 4 times x squared plus y squared minus 36y. Here we added 36y to this equation number 2, and we got this expression. Then we substituted xy plus y, x squared plus y squared by 49, because according to equation number 1 it equals to 49. Then we divided equation number 2 by 4, and we got that 9 squared equals to 49. We divided equation number 2 by 9, and we got that y equals to 49 over 9. Y equals to 49 over 9. Then we have equation number 1 that says that x1 plus y squared equals to 49. So x squared, and we already found out that y equals to 49 over 9, so y squared will be equal to 49 over 9 squared. Here we subtracted 49 over 9 squared from this equation, and then we changed 49 to 7 squared, and we got this expression. And then we use the trigonometric identity that a squared minus b squared equals to a plus b times a minus b, in order to find out, to simplify this expression. In our specific expression we have here a b squared is 0, a 7 and b is 49 over 9, so here x squared equals to a plus b, a minus b. We multiply this expression with 7 by 7, and then we divide it, we multiply it by 9, and then we divide it by 9 in order to have a common factor with 49 over 9. So we got this expression, 63 plus 49 is under 12, and 16 was 49 is 14, so in conclusion we got this expression. Under 12 is 8 times 14, so we substitute under 12 by 8 times 14. So we know that under 12 is 8 times 14, so we got this expression. And we also know that 8 is 2 times 2 times 2, so we substituted 8 by 2 times 2 times 2, and we got this expression. We took a root out of this expression, and we got this expression. The square root of 2 times 2 is 2, the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. So in conclusion we got that x squared, that x equals to 2 times 14 over 9 times square root of 2, 2 times 14 is 28. So in conclusion we got that x equals to 28 times square root of 2 over 9. Okay, then we found the area of trapeze ABDF, that is also the area of the green shape. It equals to the sum of its sides, that is to say AB plus DF times the height AD over 2, and that is also the area of the green shape. AB is y, EF is 9 minus y, and the AD is x. So here y minus y is 0, and 2 over 2 is 1. So in conclusion we found out that the green area equals to 9x, but we have already found out that x equals to 28 times square root of 2 over 9. So 9 over 9 is 1. So in conclusion, we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, thank you very much.